This is Open Up Resources, Unit 4, Lesson 3, which is Balanced Moves, and also Lesson 4, which is called More Balanced Moves. I've sort of taken out parts of each lesson and combined them into one. Before we do that, let's go over the warm-up. This warm-up was also in the last video. We have 1/4 of a group. In other words, I'm taking everything inside of that group and I am multiplying it by 1/4. So 1/4 of 12x is going to be 3x. And 1/4 of 16, or 1/4 times 16, is 4. This is equal to and balanced with. We need to be careful and make sure we are following the order of operations. I know it says 10 minus 3, but that 3 is showing that we have 3 groups of this. So I can't do the 10 minus 3 when I have to do the multiplication that comes first in the order of operations before that subtraction. And also, because I can see that we're subtracting 3 and we're subtracting on the inside of the parentheses, I'm going to change that subtraction to adding a negative so I don't make any mistakes while I'm doing that distribution. Now as I'm doing that distribution, I can see I have negative 3x. Negative 3 groups of x is negative 3x. And I have negative 3 groups of negative 2, or in other words, negative 3 times a negative 2 is a positive 6. We are adding, just because we were adding before, we're going to be adding again. That's why I change the operation to addition, so I can just focus on the sign of the number. That negative 3 times a negative 2 is a positive 6, so we're adding 6. That just takes care of the distribution. I still need to add 10 to that side of the equation. And in the same step, I'm also going to bring down everything else that I simplified in the previous step. So that left-hand side comes down as is, because it's already simplified. The right-hand side, I took one step. Now I'm going to take the final step in simplifying. I have 10 unit tiles here, 6 more unit tiles here, for a total of 16 unit tiles. So 16 plus a negative 3x on the right-hand side, which is now completely simplified, and it's equal to and balanced on the other side with 3x plus 4. I have 3x tiles here and negative 3x tiles here. In order to zero them out, since these are negative, I need to add 3x tiles. Same thing over here to the other side. This is now zeroed out. So even though I had x tiles over here, they're now zeroed out. And since I balanced it, I now have 6 x tiles plus 4 unit tiles, which is equal to and balanced with the 16 unit tiles on the right-hand side. From here, we just subtract 4 from each side. And I end up with 6x is equal to 12. Divide each side by 6. And we get x is equal to 2. A lot of mistakes were made on this quick pull, so will you please now share your mistakes with your group so that you can learn from your mistakes so that we don't keep making those same ones. Ready, set, go. Thanks. Charlie. Okay, so you just forgot this guy completely. Okay. That's going to be one of those mistakes that happens a lot, which is why throughout this whole entire unit, as we've been practicing simplifying expressions and solving equations, I've always wanted you to show your work in a really particular way. Because if you take the time to just bring everything down from the previous step, except for the one thing that you're simplifying, it's a lot harder to miss those kinds of things because you just bring everything down. So we definitely can learn from that mistake. Thank you for sharing. Brock. Add the 10. Okay, so that's the thing though, is if you do that, you still can be successful as long as you don't lose any other information along the way. So if we did come back to this point, so Brock, I'm going to do what you said, and let's see if we can find your new mistake, because it is okay to do that. It's not ideal, but it is okay. So at this point you're saying, okay, simplified, simplified, it's not, but let's pretend like that's what we think. We can subtract the 6 from this side as long as we balance it and subtract the 6 from this side as well. We can do that. Did you subtract it from the 10? Ah, so that's a key thing. Whatever you do to one side, we do to the other side. So when you are, if we do this, this is okay. But what you did is if you subtract 6, you're not balancing anything. You're subtracting 6 twice from the same side. If we make that change and subtract it from the other side, we would still be okay. I'm just going to follow along with this to show you it's okay to do this. 4 plus a negative 6 or 4 minus 6 is going to be negative 2. And that's equal to and balanced with 10 plus a negative 3x. At this point, we're still going to be left in kind of the same situation where I would add 3x to each side. Still going to leave me with 6x minus 2 this time, which is equal to 10. Here we had 6x equals 12, or 6x plus 4 equals 16. If I add 2, you're going to see that it gets us right back to that final step from the last one. So it is okay to do that as long as you do it to the other side. Okay, really good lesson to learn there too. Thank you for sharing. Last one, Emery. This 3 or this 3? Ah, okay. So you did 10 plus a negative group of x plus a negative 2? Okay, so that's just kind of a transcription error, just forgetting to copy something down. Good. Thank you guys for sharing. We can learn from our own mistakes and we can learn from the mistakes of others, so I really appreciate you guys doing that. So back to Unit 4, Lesson 3, Balanced Moves. All right, we are back to some balanced hangers, just like we've seen in previous lessons. But what we see here is hanger A, and then B, and then C, and then D. They all represent the same balanced hanger at different stages of simplifying. So I want you to kind of follow along and see what's happening. What's the transition from A to B, then from B to C, then from C to D. And as you're doing that, we also have these equations. These equations each represent the hangers, the different hangers. So the same equation in different stages of that simplifying. So work with your groups and try and figure out first what's happening from A to B. How is it being simplified? What's the change? B to C, how is it being changed? What is the simplifying step, and so on. When you finish that, start matching these equations below with the hangers above. I'm going to pause the recording to make sure you have a chance to do that. Ready, set, go. What's the simplifying step that they did to go from hanger A to hanger B? Emma? Yep. We subtract the 2 circles and balance it by subtracting the 2 circles on the other side. This is where you started to struggle. How do we go from hanger B to hanger C? Notice what's missing. We have a square and 3 triangles missing, and we have 2 squares and a triangle missing on the other side. So be careful how we think about that. Timothy? Yeah, that's what they really did. They divided by 2. With that new information, take a look and see how that makes sense. And see why it doesn't make sense to say take away a square and 3 triangles, because do we have 3 triangles to take away here? And not only that, they took away 2 squares and a triangle. So we can't think of it as taking away, because if we're taking away, we got to take away the exact same thing from the other side. So instead, if we think of it as division, it makes a lot more sense, where we have a square and 3 triangles. That's one group. A square and 3 triangles. That's a second group. And here we have a square and a triangle that could be one group, and 2 squares and a triangle that could be another group. So when I'm dividing it by 2, I'm getting rid of one whole group and getting rid of one whole group that would include 2 squares and a triangle. And that is exactly what we have left. So yes, this is dividing by 2. And the final step, what's happening from here to here? Thank you. Seth. Yes, and this one we can think of as subtraction because we do have a triangle on each side to get rid of, so we are subtracting that. And we do have a square on each side that we can subtract and get rid of. And that leaves us with the 2 triangles is equal to a square. Now match that, and to clarify, I just need to make sure that you understand there is a typo in how this is formatted. It says write the equation that goes with each figure and then step 2. This is all one thing. So get rid of that number 2. Write the equation that goes with each figure, hanger A. Which one is it? It's kind of a multiple choice. You have these ones up here to choose from, and make sure that you can make sense of that. Hanger A, hanger B, hanger C, hanger D. What does a triangle represent? What does a square represent, etc. So you can kind of do 1 and 3 together. Now that we have figured out what's going on here, take a second now and converse about this. Match the hangers with the equations. Pause the recording one more time to get that done. All right. Thinking of hanger B as groups, I think also helps us understand what we're seeing in the equations. We have a group of a square and 3 triangles, but we have 2 of those groups. So when I'm seeing this equation here, a single thing and 3 other things grouped together, and we have 2 groups, it makes sense what we're actually seeing. So this one here is hanger B. This one here is hanger D, A, and C. We also could have written it a little bit differently. Hanger A would be 2 groups of x plus 3y plus the extra 2z, which is equal to the 2z plus 4x plus 2y. Hanger B, 2 groups of x plus 3y, which is equal to the 4x plus 2y, only difference being that we subtracted the 2z from each side. This is an interesting step to take here. Remember, we're dividing each side by 2. So if I divide by 2, we get rid of that second group. But I have to divide everything by 2. So 4x divided by 2 leaves us with 2x, and 2y divided by 2 leaves me with 1y, which is how we get to x plus 3y is equal to 2x plus y. And then we can subtract the things that we have in common on each side, subtract an x here and a here, subtract a y here and here, and that's how we get the final hanger 2y is equal to x. So each variable x, y, and z represents the weight of one shape, which goes with which? X, y, and z. X is what, Siley? Yes, x is the square. I didn't copy and paste anything. I didn't even cheat that time. You can't be jealous of technology when I'm not even using it to my advantage. Y. What is y? Caden. Yeah, y is a triangle. And z is the circle that we got rid of right at the very beginning, right? Which is why we only saw it in the first one and we didn't see it in any of the others. Explain what was done to each equation to create the next equation. We saw that when we talked about it up here. But we can really take a look at as we transition from hanger A to B to C to D. Again, we took away our 2 circles, so I subtracted 2z from each side. Then we divided everything by 2. This was in 2 groups, so I divided that by 2. This was not in groups, but I divided everything by 2. So again, this is what's really happening. Dividing the whole entire side by 2, so that divides out. Dividing this whole side by 2, but dividing it by 2 piece by piece. So 4x divided by 2 and 2y divided by 2. I'm still dividing everything by 2, I'm just doing it piece by piece. And so you can see that transition into hanger C. And then from there, we subtract x from each side and subtract y from each side. Let's do it on our own. Now that we've seen it, we've talked about it, let's actually do it and show the work. We have our 2 groups of x plus 3y plus 2z is equal to 2z. Do you guys see why I put lines through my z's? Without, they look too similar to a 2. You don't have to, but it is a good idea. So that first step, we subtracted those circles. So subtract 2z from each side. Again, notice what I'm doing. I am subtracting 2z from the whole side, but look at where I'm writing it. I can't take z's away from x's or y's or anything else. So I am writing it right below. That way it's easy to see that it zeroes out. But I am subtracting it once from each side, or I guess twice, 2 z's from each side. So with that zeroing out, what do I have left? 2 groups of x plus 3y, which is equal to and balanced with. That zeroed out, so 4x plus 2y. Again, that next step, we are dividing each side by 2. So again, dividing the whole side by 2. I'm going to divide this whole side by 2, but I am going to do it in pieces. Since it's in pieces, I'm going to divide every piece by 2. And it's okay to do that. This divides out, leaving me with x plus 3y, which is equal to 4x divided by 2 is 2x, and 2y divided by 2 is just one single y. We're not used to seeing equations that have all these extra variables, but our process is still the same. If I have an x on each side, let's get rid of that x from each side. In this same step, if I want to, and I'm only doing this just because that's what the hanger did. I don't love doing it in the same step, but since I have a y on each side, I can also get rid of the y that's on each side. X minus x, that zeroes out. 3y minus a y, that's 2y. 2x minus an x, that's 1x. Y minus a y, that zeroes out. So again, the things that I've taught you about showing your work step by step, about bringing everything down, pulling everything down and showing your work in that specific way is going to be really helpful as these equations get bigger and more complex. Okay, let's move on. 3.3, keeping the equality. Here's a new equation. We're back to just one variable because that's all that we really need to do. And when we're not dealing with a hanger and shapes, it's better to just keep it simple. So Noah and Lynn both solved this equation. 14a is equal to 2 groups of a minus 3. Here's Noah's solution and all of the work. Here's Lynn's solution and all of the work. See if you can figure out what their steps were. What are the steps that they took? Do you agree with them? Do you disagree with them? What do you see as happening? Don't move on to number 2 until we've had a chance to talk about this, and you're going to talk about all of this with your groups first. Pausing the recording as you discussed. Ready, set, go. Okay, let's talk about it. Do you agree with either of them? I heard interesting comments as I walked around the room, so I'm curious to know who is going to share their thoughts. Sam. Yeah, I would agree with that too. Before I even do anything else, don't they both come up with a is equal to negative 1/2? Yeah, so either they both did it right or they both did it wrong, probably, right? Okay, let's go through Noah's steps. What did Noah do? Danielle. Yep. Exactly. He simplified, or in other words, he used that distributive property. We no longer have the parentheses here because he multiplied across those parentheses, and that's exactly right. Let's follow the rest of his work. After he distributed, then what did he do next? Or, yeah, what did Noah do next? Hayden. Yep, subtracted 2a from each side. That's how I have 12a, which is equal to, notice he didn't just put 6, he put negative 6. Yep. And final step, what did they do after that? Emma. Divided by 12. Negative 6 divided by 12 is now going to give us a by itself, and a is equal to negative 1/2. So, did Noah do it correctly? Yeah, it works. Let's look at Lynn. What did Lynn do for the first step? What did Lynn do? Seth. I don't know that we can say that Lynn made it 2a minus 6 because I don't see that step. So you guys are used to doing that distribution because that's part of simplifying. But I want us to compare what we see here to what we saw in the warm-up. Instead of calling this 2 squares and 6 triangles, we can keep them in their separate groups and then just divide by 2. So that's what Lynn did. right out of the gate, Lynn says, why am I going to waste my time doing the distributive property when all I really have to do is just divide each side by 2? There's no need to distribute if you're just going to divide it out. So that's what they did. If I have 2 groups of a minus 3 and I'm dividing it by 2, what do I have left? A minus 3. And 14a divided by 2 is 7a. That's really important. Let's make sure that we take note of what it is that they did. Noah distributed first. Distributing is one of those steps that we take when we simplify. And Lynn says, why waste my time distributing when I'm just going to divide it out anyway? So don't distribute, divide out. All right, let's follow along with the rest of it. Now we have our 7a is equal to a minus 3. Next step, how'd they go from here to here? Maverick. Yep, took away an a from each side. Subtract out this a, now it zeroes out. Subtract out this a to balance it. 7a minus a is 6a. So I have 6a is equal to negative 3. And what do I do now? 6a is equal to negative 3. Is that Gracie's hand over there? I can't tell. Gracie. Yep. Take the 6a, divide it by 6. Take the negative 3, divide it by 6, and that's how I get a is equal to negative 1/2. Now, you've seen it 2 ways. I'm just curious. Who likes this way better? I'm not surprised. We've been practicing a lot on distributing as part of our simplifying. That's fine. Who thinks that maybe they could get used to this? Yeah, ends up being a little bit easier. You save yourself the step of distributing. You're not going to make mistakes if you can just divide out right away. It's okay if you still do it this way. I just want you to see that sometimes this maybe is a little bit easier, a little bit more strategic. Elena is asked to solve 15 minus 10x is equal to 5 groups of x plus 9. What do you recommend that she does to each side first? And again, take a look at what Noah and Lynn did. Could we solve it Noah's way? Could we solve it Lynn's way? Talk with your groups and figure it out. When you're ready, you can also move on and start discussing Diego. Talk with your groups. Pausing the recording. All right, let's do this both ways. Solving it Noah's way. 15 minus 10x is equal to 5 groups of x plus 9. Noah would probably distribute first. So 15 minus 10x is equal to 5 groups of x and 5 groups of 9, which is 45. I'm going to go ahead and get rid of this negative 10x because I don't want to deal with negatives, so I'm going to add 10x, zeroing that out, add 10x to zero that out. Now I have 15 is equal to 15x plus 45. We can subtract our 45 from each side. We are still going to deal with the negative, but not negatives in the x's, so I'm still okay with that. 15 minus 45 is negative 30, which is equal to 15x. Now you can be jealous of my technology because I am going to take advantage of the technology to move my work up a little bit. Divide each side by the 15, and I end up with negative 2 is equal to x, yeah? Okay, now let's do it Lynn's way. What would Lynn have done differently? Maverick? Divide what exactly? Exactly, yeah. Instead of distributing the 5, let's just divide it out. Divide this side by 5. Divide this whole side by 5, but I am going to divide it in pieces. I'm still dividing everything by 5. The whole side is being divided, just doing it piece by piece. 15 divided by 5 is 3. Minus 10x divided by 5 is minus 2x. And that's equal to, this divides out, so I have x plus 9. And I'm going to do the similar thing. I don't want to have to deal with negative x's, so I'm going to add 2x to each side. And it leaves me with 3, which is equal to x plus 2 more x is 3x plus 9. Subtract 9 from each side. Now I have negative 6 is equal to 3x. I still didn't create enough room for myself here. We're going to divide each side by 3 and end up with the same answer that we did doing it the other way. Divide each side by 3. And we get negative 2 is equal to x. Quickly take a look at number 3. Are we going to be successful using Lynn's method here? Let's try it. If I divide this side by 4, I have to divide everything over here by 4 too. Just going to divide everything but in pieces. Mathematically speaking, is that going to work? Why not? I mean, if I'm dividing everything by 4, it should still be balanced, right? So is it going to work mathematically? Yeah. Is it going to be as easy or as nice? That's the answer. Yeah, no. 3x divided by 4. Now we have a messy 3/4 x. Minus 2 is equal to x plus 5. So could we do it? Do you want to deal with 3/4 x? No. So again, just making sure that you recognize, yes, there are multiple strategies, and we absolutely can use different strategies. Sometimes it doesn't always work out the best. So I want you to finish this one up for homework. If you've already done it, great. Solve it any way you want to, probably by distributing. We're going to end the video here and continue this lesson on another one. Thanks for watching. We'll see you next time.